So I've got a PVM 5041Q here. It's one of the 5-inch portable PVMs. And someone brought it to me with an issue where the composite input doesn't work. Sorry about the noise, that's my son in the background. This particular monitor has two inputs on the back. It has composite and RGB / component that's switchable. And when you turn it on, you can hear, let me turn the music down. You can see that if I switch the sync to external, let's see, it's all plugged in there. What's going on here? Okay, so there we go. So you can see that it works fine on the RGB input. But when I switch it to composite via this line RGB switch, it still just keeps displaying RGB. And I've noticed that when I go to the composite input and just observe the RGB signal, which it may or may not do right now, I actually will get some interference sometimes, both on the audio and the video, from the composite input being combined into the RGB input. Yeah, it doesn't seem to be doing it right now. Right now I have a Wii hooked up via composite as a test. And so this is a pretty perplexing issue. But what I ended up tracing it down to, let me turn this equipment off. I traced the whole circuit for composite video, you know, the Y video. I traced it through the whole signal processing board, which is the B board. And I found that the signal makes its way all the way through until right before it gets to the RGB buffers, actually before it gets to the Y buffer, which then leads to more processing before it gets converted to RGB. It dies right at this IC right here, IC 104. And if you look at the schematic here, you can see that it's a basic logic. It's a 3 input 1 output, you know, switching IC. So there's an input here at pin 1, there's an input here at pin 3, and there's an input here at pin 5. And the switches between pin 5 and 1 or 3 is right here, controlled by pin 4 voltage. And there's another switch here to switch between 1 and 3 via the pin 2 voltage. And I figured out pin 5 is just dead. It's not even used. I don't know why they used a 3 input switch here, but they're only using 2 inputs on it. And the 2 inputs it's switching between is composite video right here on pin 1 and ground or nothing on pin 3. So if this switch is pulled high, which means a high voltage, it will pull from ground, which disables composite video from coming through. If it's pulled low, which means a low voltage, it will pull from pin 1, which is where the video is currently sitting, stuck. And so this schematic has numbers written on it, but I have no idea what the hell any of them are supposed to mean. It has 3.5 written for pin 2, which I assume means that anything above 3.5 volts will be considered being pulled high, but I actually found the data sheet for this online right here, and you can see this is the same circuit layout. It's laid out a little bit differently, but the pin out is the same, the logic gates are the same, and it's the chip that we're dealing with. And if you look at the tolerances for what's considered a high and low voltage, switch 1, minimum for a high voltage is 2.1 volts, and maximum for a high or a low voltage is 0.7 volts. So it has to be between 0 and 0.7 volts to be pulled low, and it has to be anything at or above 2.1 volts to be considered high. So in other words, this IC will never let composite video pass through it unless the voltage to the switch pin is at or below 0.7 volts. Okay, so let me get my probe here so I can do some pointing. Let me zoom in the camera. This little guy right here is IC 104. All right, that's the IC we were just looking at. Okay, and on the top row here, starting from here, that's pin 5 through 8, and this is pin 1 through 4. So if we probe pin 1, we should see composite video coming through. So let me set that probe up. It's a little bit difficult on these stupid little pins for these ICs, but I'll get it. There we go. So we'll turn the CRT on, and we'll look at our oscilloscope. So what you're seeing there on the top, the yellow line is that red input on channel 1, and that is a direct pull from the composite video. I have a splitter back here. So that is unaltered composite video straight from the source. And what you're seeing on the bottom on channel 2 on blue is the input being sent to pin 1 of IC 104, and you can see it's the composite video signal. There's a little bit of noise, but that's not important. That's negligible noise. So we know the video is getting there, and if we look again at this schematic, pin 7 is the output. After all these switches from various places have been dealt with, pin 7 would be the output. So the ultimate question would be, are we getting any output on pin 7? So I've got the probe there on pin 7, and we aren't getting anything. So nothing, just noise. You can see there's a little bit of noise, but no signal. So that confirms that the video is dying within this chip. But then the question is why? And it's because, which I'll show you here, it's because that switch that we said had to be below 0.7 volts is always being pulled high no matter what. And it's way higher than the spec. Let me find my multimeter probe. There we go. All right. Pull this cap off. Now, pin 2 was the location of that low switch, or the high-low switch that we were talking about, right? So, pin 2 is right there. And let's switch the multimeter on to volts. And we're getting 3.4 volts. Right, and that's with the line switch turned off. So if I turn it on for RGB mode, we're still getting 3.4 volts, 3.435. If I turn it off again, we get 3.419. So it's literally only changing by 0.02 volts between the two switches. And 3.4 volts is way above and beyond the spec for what's considered pulling high on that switch. So that's very strange to me. So then I figured, okay, well, where, you know, what's happening to the voltage on this line switch? So I traced it, and we can start at the beginning here. This right here is all of the inputs coming from the input board, which is not important, but sorry, I keep making that noise. So here's RGB line. This is the RGB line voltage circuit that's controlled by that switch. So the only things that touch it is C capacitor 1300, which is a 1 UF 50 volt capacitor, which I already tested and it's fine. So let's continue down the line following this circuit, see where it takes us. Okay, so right here it's being tapped, so let's follow the tap. And it goes through a resistor, a 47K resistor, R1034, and then straight into pin 2 on that problematic IC that we're looking at. So interesting. It's a very simple circuit. So as I said, I tested C1300 and it's great. It's working fine. But what about R1034? Is it working? Well, R1034 is right here. If you can see that, it's this guy right here. And if I zoomed in on this and could see that it said 473 on top of the SMD resistor, which is the code for 47K. So that matches the schematic. So we have an up-to-date schematic. Sometimes you'll find that the schematics get revised later and you have an earlier revision of a schematic than the board you're actually looking at, and that becomes a problem because some of the components have been changed and you don't have the new values. So it's always best to try and read the values straight off the component when possible. So we can take our probes here, and this is going to be a little bit difficult for me to do on camera. Let me see if I have a tripod here. Okay, so I could not find a tripod, but I managed to do it one-handed here. So I've turned the TV off because you can't measure resistance when there's current flowing through it. And I've put the probes on either side of the resistor, and what's the resistance? 16.4K. Less than half of what it's rated for. Which would explain why the voltage that I'm reading is more than double what it's supposed to be in order to actually trigger the gate on this IC. So I'm thinking that all I need to do to get this input working again is get that resistor to give me the proper voltage levels for that switch on the IC, and then we'll be back in business. So I ended up investigating this issue more, and I pulled that resistor off the board, and it turns out that it just was not measuring correctly in circuit, because once I pulled it off, it was measuring the correct 47 ohms, so 47 kilo ohms. So I'll put that back later. For now, I've just replaced it with a normal 47K resistor. What I found out is that after adding resistors here to actually bring down the voltage myself from the 6 volts all the way down to 0.6 something volts, this chip started functioning properly. It output the composite video as it's supposed to, and the video traveled all the way over to this group of ICs over here. One's for R, one's for G, and one's for blue. It splits the signal, and all 3 of these chips were still turned off because they were also getting the wrong voltage to their switch pin 2. So that told me that this whole board has a problem with the entire RGB line switching circuit. And that circuit runs on 12 volts, and after testing, I decided to test the other switches, the HV delay and the underscan switches, and those both function the same way, where they run on the 12 volt circuit. And I figured out that they just pull ground when they're toggled off. It's not like a voltage change where it's, you know, there's added resistance. It just switches off the voltage completely. So that told me that there was something definitely wrong with the way that the line RGB circuit's working, because when I toggle it on and off, it just changes voltage. It doesn't pull ground ever. So then I went through all of the schematics for all of the boards and had to figure out where the 12 volt is even coming from for that circuit, and turns out that it is coming from there. I actually never found it on this board, but it's coming from the D board. It's coming from a step down regulator. The D board gets 15 volts from the G board, the power board, and steps it down to 12 volts, powers a bunch of ICs off of 12 volts over here, and then sends it off down this cable here, one of these cables, through to here on the B board. And so the B-board takes that 12 volts, powers a bunch of ICs off of it, and never touches the 12 volts to the RGB line. So that told me the problem does not exist on the B-board, because the B-board does never inject 12 volts into the RGB line anyway. So it's not powering that circuit. So then I followed the schematics for the controller board, the HB board on the front. That connects right here and goes to the front panel, and this switch bridges between ground and 12 volts, which is sent by the D-board. So this panel takes care of the 12 volts injection, and there's no issues with the switch operation. I tested the switch, it works perfectly fine. The operation of this board is perfectly fine. So I thought, well, where the hell else would 12 volts be injected into the RGB line? So that took several more hours of looking at the schematics before I figured out that actually on the input board, you know, the one with all the inputs on it, it has a external remote plug right here, and pin 8 of that external remote controls RGB and line toggling. So if you look at the schematics for that, which I believe I have pulled up right now, yes, so that is right here. You can see that pin 8 is the RGB line. So okay, where does it go? It goes over, and it goes up, and it goes over through a resistor, through a filtering capacitor, and then it goes into a transistor. And that transistor is collecting from the 12 volt line. You know, it's a basic 3, it's a 1 input transistor, and it has a collector for voltage, and it has an emitter for output. The emitter is supposed to be 0 volts, as it says here, all the time, unless the remote toggles the control, and then the transistor will collect 12 volts from the 12 volt line and send it through the RGB line toggle circuit. So Q402, that transistor, is right here, and I have it off the TV right now, so I won't actually be able to do any voltage readings. But if you look at it right here, here is the input from the remote, which is up here. That group of 8 pins is the remote input. Here's the input, here's the collector from 12 volts, and here is the emitter. And so I measured each of these with a multimeter, and I got 11 volts on the input, which means that it's emitting, because I got 12 volts on the collector and 6 volts on the emitter. And so that tells me that this this transistor is failing, because it should either be putting out 0 or full voltage from the collector. It shouldn't be putting out half the voltage of the collector. So it's leaking 6 volts all the time. That's the source of the problem. So I'm going to go ahead and take this off of the board and see if the problems go away. So I was getting ready to take this transistor off the input board when I decided to take a look at the actual remote controller input, right? And out of curiosity, I looked at the schematic and found that pin 8 is right here. That's pin 8, the top right pin. And I don't know if you can see it on the camera, but to me, it looks like that pin hole, as well as the one down here, have broken pins in them. And so now I'm wondering, let me see if I can get my tweezers in there. Now I'm wondering if maybe this pin being in here without a ground connection is causing the leakage with the transistor, and I can't grab that pin with my tweezers, so I'm going to go ahead and remove this plug. and see if I can verify that there's a pin stuck in there, and we'll go from there. And if there's no pin and no issue with this remote plug, then I'll go back to blaming the transistor. Well, would you look at that? Working composite and a working switch. So I was right about that transistor being the source of the problem, but there's nothing wrong with the transistor, and I was right about this damn remote port. I can't even see it. I've examined it with a flashlight shining through both ends. I couldn't see it, but there had to have been a pin stuck in this, like I thought, because when I removed this stupid remote port, everything fell into place, as you can see, and it works fine. This is the composite input from a Wii, which you can see when I unplug the composite, it pops out. And let me go ahead and hook up RGB just to make sure that's working fine. All right, we're in business. RGB is connected back there, and it works just fine. And if I toggle off RGB and flip the sync switch on the back, we got the composite input from the Wii with no interference. So this one, the case is closed on this guy, and time to pack it back up. Gotta put the board back on the back because it's just bare metal back there, and gotta button this back up and reconnect some ground wires, but this one's good to go.